Hey guys, let's talk about 19.4, mutually exclusive and overlapping events. So a mutually exclusive event is an event that are events that cannot both occur in the same trial of an experiment. So like mutually exclusive, you probably heard that phrase before. It's like two things that can't happen at the same time. Like pizza, if there's one piece of pizza left, either I eat the pizza or you eat the pizza. If I eat the pizza, you can't eat the pizza, and if you eat the pizza, I can't eat the pizza. So that's a mutually exclusive event. So our little formula here for finding for mutually exclusive events, if A or B occurs, it's the probability of A occurring plus the probability of B occurring. Done. Our addition rule, the probability for the probability of A or B, our formula for that is the probability of A plus the probability of B minus the probability of A and B. This is kind of a lot. I'll show you what I mean with this example. Most of your homework is just tables, which is super convenient because all of your, remember, so our formula for probability, the probability that some event will occur is the number of possible outcomes in that event over all possible outcomes, right? So in this particular case, we want to find the probability that a headache or someone didn't take medicine happened. So when we follow this formula here, probability of A or B happening is what we want to find, right? A or B, headache or no medicine. So we need to find the different pieces of this, right? We need to find the probability of A, we need to find the probability of B, and we need to find the probability of A and B, so that we can fill them into these pieces of our formula and we can find the probability of A or B occurring. And we're going to use this guy for every single piece. So to find the probability of A, probability of B, or the probability of A and B. Okay, so let's start with our first piece of information here, our probability of A, right here. So probability of A is headache, right? Headache, okay. So if A is the probability that a headache will occur, we need to find our total number in that event over all possible outcomes. So we conveniently have all of that information right here in this table. All possible outcomes for every single one of our probability fractions is going to be 100. So 100 goes on the bottom of all of our fractions here. It'll be on the bottom of PA, PB, and PA or B. So that part's done. That's nice. So let's look at the probability of A. The probability of A is that a headache occurred. Okay, a headache. It doesn't matter if they took medicine or didn't take medicine. We just want to find probability of a headache. All right, our total is 27 headaches. Okay, so 27 over 100. That's the probability that someone in this study had a headache. Okay, great. Now let's look at the probability of B occurring. The probability of B is no medicine. Okay, here's no medicine, and our total for no medicine is 40. Great. 40 over 100, that's 2 over 5. This information is right here in the table for us. We don't have to guess. We don't have to do any calculating. It's right here for us. So no medicine, doesn't matter if they had a headache or not. It's just they didn't take medicine. And that's 40 out of 100. Okay, let's take a look at our A and B. Okay, A is headache, B is no medicine. So headache and no medicine is right here, 15. So 15 out of 100. Let me highlight that 100. 15 out of 100, or 3/20. Okay, now that we have all of the pieces of our formula here, so the probability of A or B happening is the probability of A, which was 27 over 100, we got from there. The probability of B was 40 over 100, which is 2/5, we got there. And the probability of headache and no medicine is what we subtract, is what we got from there. And now we're just adding or subtracting fractions. So this is 27 over 100, right? There we go. So we had 27 over 100 plus 2 over 5. I need the denominators to be the same, right? So that I can add them together. And 2/5 started as 40 over 100 minus our A and B, right? Which is our 3/20 or 15 over 100. 15 over 100. Okay. 27 plus 40 minus 15 is 52 over 100. And then we just need to reduce, right? Let's see, we can divide both of those by 4, and that gives us 13 over 20. There we go. So for these homeworks, almost all of them are going to give you a table. So get the information that you need from the table and follow this formula. I think all of them will say A or B. All right. So if you have any questions for me, shoot me an email. I can set up a Zoom meeting with you if you want to do one-on-one. If I can't answer it over email, I can do a tutorial with you online. Also, the Zoom tutorials are changing. The vote's still out. I'll let you know on Friday. Right now, it's looking like it's probably going to be Tuesdays and Thursdays. But the two choices are Monday, Wednesday, or Tuesday, Thursday. I'm still taking those votes through Friday. So if you want to log on Google Classroom, and you can fill out that Google form, and whatever wins is what we'll do. All right, bye.